Soybeans are primarily grown for their oil content, and a byproduct of the oil extraction process is soybean meal, which we use as a protein ingredient in our poultry diets. But when that oil component of the soy is extracted, it's extracted as crude oil. And it has to go through several steps of purification in order to result in the refined soybean oil that we use for, food applications, industry applications. Through that purification process, different solvents are added, such as sodium hydroxide and phosphoric acid. And these ingredients precipitate out the impurities in the oil, which are known as add backs.
Hello, everyone. Welcome to another episode of the Poultry Nutrition Blackbelt Podcast, where we discuss the latest in poultry nutrition research and industry trends in approximately 10 minutes. My name is Sam Rochel. I'm one of the co-hosts of the show, an associate professor at Auburn University, and today joined by one of my former colleagues at my old department at University of Arkansas, Savannah Wells, who is a PhD student kind of nearing the end of her program there at Auburn. And so we're going to talk about some of the research that she's been working on. So Savannah, as always, great to see you and talk with you. How you been?
Great to be here. I've been great.
Yeah.
Thanks.
So what's so you have a unique background in how you got into poultry. So you kind of came from not necessarily from the animal side of agriculture, but more on the crop side. So can you talk a little bit about that and how that's ultimately led to your current interest in your current research topic?
Of course. So I'm originally from Northeast Arkansas. I grew up in Paragould, Arkansas on my family's row crop farm. My family farms around 1,500 acres of corn and soybeans. And when I started my undergraduate degree program, I went to a university near my hometown called Arkansas State University. And through the program there, I joined their animal science bachelor's degree program. And through that program, I learned about a wonderful opportunity known as the 3+1 dual credit poultry program with the University of Arkansas, where students can attend 3 years at Arkansas State University and then transfer their fourth year to the University of Arkansas and get 2 bachelor's degrees, one in animal science from Arkansas State and one in poultry science from the University of Arkansas. And through that program, I had the opportunity to take a lot of nutrition classes, which I absolutely fell in love with because it connected the side of agriculture that I had grown up around, row crops, with the side of agriculture that I was interested in, which was animal production. So as many are aware, the 2 main components of a poultry diet are corn and soybean meal. And so that just felt like exactly where I needed to be. And after I finished my bachelor's degrees, I started grad school and have absolutely loved it.
Well, that's awesome. And so, it's great that you were able to translate that into an actual research topic around this area. So you've been working on soybean add backs and soybean genotype selection, different nutrient composition. And I remember your talk at PSA talking about, different co-products of soy and energy values. So let's just jump into that first. If we talk about soybean add backs, that's kind of an industry term. Can you talk about what that means, soybean add backs?
So soybeans are primarily grown for their oil content, and a byproduct of the oil extraction process is soybean meal, which we use as a protein ingredient in our poultry diets. But when that oil component of the soy is extracted, it's extracted as crude oil. And it has to go through several steps of purification in order to result in the refined soybean oil that we use for, food applications, industry applications. Through that purification process, different solvents are added, such as sodium hydroxide and phosphoric acid. And these ingredients precipitate out the impurities in the oil, which are known as add backs. And these are lipid-based compounds. The first one is soybean gums. which are composed of phospholipids, and then soybean soap stocks are more free fatty acids and mono and diglycerides. And so these are not, refined soybean oil, but they are soy lipid products that we wanted to research and see if they could be incorporated into poultry diets as an energy source.
Yeah, no, very interesting. I mean, I think some people have a general idea that we get soybean oil from soybean meal or from soybeans, and then that creates the oil in the meal. But, there's all these other co-products that people are probably less, about. So you talk about the gums and the soap stocks. Are these going to be liquid at room temperature like soybean oil, or are they going to be, once they're precipitated out, they're going to be a drier form?
They're still liquid. They are more viscous than soybean oil, and they contain a lot of water.
Uh-huh.
So in our research, the soybean gums and soap stocks contained roughly like 30 to 40% moisture content in those ingredients, because water is needed to remove them from the oil.
And then what about the fatty acid profile of those? Is it similar to soybean oil, or does it change quite a bit?
It's similar in many fatty acids, but it differs in others. Soybean oil, for instance, one of the great qualities about soybean oil is that it contains a higher amount or higher amount of oleic acid.
Sure. Mm-hmm.
And these ingredients are lower in oleic acid compared to that of soybean oil. And then they're also higher in linoleic acid, which is something that we try to, reduce in soybean oil. So it is similar, but it does differ at the same time.
And then I know like the soap stocks generally have higher free fatty acids. Is that the same for the gums too?
The gums are mostly phospholipid based.
All right. And so you've done some work on using these. So how would these typically, where does the value come in these, as feeding as individual products or blending them with other things? What do you see the big potential there?
So the motivation behind conducting this research is that due to the expansion in soybean crush, we're now producing a lot of these add-backs ingredients. And the thought is that they can be incorporated back into the soybean meal to produce a higher energy content soybean meal. And so that's typically how they're used. I think they can be incorporated into the meal up to levels of 4% before it's dried. And so then, they're added in, the soybean meal is dried, and that removes that moisture fraction of those add backs. And so when we conducted this research, we initially started with a broiler performance test in which we utilized 5 dietary treatments. We had a control diet, which was just a typical corn, soybean based diet. And then we had our experimental diets, which were formulated to have a basal energy level that was the same as that control diet. And then we added in the add-backs ingredients at levels of 4%. So either 4% gums, 4% soap stocks, or a mixture of 2% gums and 2% soap stocks. And then we also had a negative control diet in which we just added in filler at a level of 4%. So that was what we started with. And for that, we assessed live performance, processing characteristics, body composition. And then from that research, we've now conducted a series of 4 research trials with Dr. Parsons' lab here at the University of Arkansas that looked at determining the exact energy levels of these ingredients through precision fed rooster assays, restrict fed broiler assays, and then also ad libitum fed broiler chick assay.
So with all that, what are your kind of thoughts on the energy levels, at least kind of general ballpark or relative to other, energy, concentrated energy, soybean oil or poultry fat? How does the energy kind of line out?
Yeah, so we use soybean oil as our reference ingredient. So compared to soybean oil, on a as-fed basis, these add-backs ingredients contain anywhere from around 40 to 50% of the energy level
right.
to that of soybean oil. However, if you correct this for their high moisture content and look at it on a dry matter basis, it's 70 to 80%.
Okay. Yeah.
And, these are the ingredients that we're trying to get rid of.
Yeah.
So that provides a really good opportunity for a low cost energy source.
Great. Well, I mean, it's awesome work. What other, anything other than just the energy factor? Is it strictly just the energy and costing? Are there other, secondary effects of these ingredients at all you've looked at or thought about or would like to look at?
Nothing that I've investigated myself. I don't know what research would be out there on secondary effects of these addbacks. All of this research is so new.
Yeah.
Anyways, the only researcher I know right now who's also conducting research similar to this is Caitlin Gaffield at Kansas State University, and she does it in swine. And we were able to collaborate with her on our first trial.
So the relative energy values, say, to soy oil in poultry for these addbacks, is it similar kind of relationship in swine, or are they seeing something pretty different?
I would have to, on that one, I would have to go back and look at her literature because I know that she saw, she hasn't calculated, from my understanding or what I know, she has not determined energy values for these ingredients. She's only done performance testing using these.
Yeah.
Kemen calls all poultry experts. You already know the key to a profitable operation is healthy, productive birds. Our team of poultry experts are driven by curiosity to develop science-backed ingredients and solutions that help you maintain feed and water quality, improve intestinal health, optimize nutrition, and eliminate pathogens. Learn more today by diving in at kemen.com/poultry to learn more.
Okay, very good. So what's next as you kind of wrap up the story on the soybean addbacks?
For me, personally, there's nothing left. I don't know what the future of addbacks research will look like. As I said, I've conducted now 5 research trials looking at these ingredients. Not only looking at them in broiler performance testing, also determining the energy values and the bioavailable energy of the lipid ingredients themselves, and then also looking at the same, but for the soybean meal with these addbacks ingredients included. I felt like that was a very robust amount of research to conduct for myself personally. And since I will be finishing my degree soon, I don't think there's any further research for me. I personally would be really interested in looking at the inclusion rates of these addbacks ingredients in soybean crush plants across the United States. So just like a meta-analysis of what fraction, how often these ingredients are incorporated into the meal and at what fractions.
Right.
Maybe not any broiler testing with this, but just more information about these, how often they're used in the meal.
And so when we see some of the variation in like ether extract, so say we pull a soybean meal and we get an ether extract, ranging from anywhere from 0.5% up to maybe 2% or something. I mean, is a lot of that variation not the oil, but it's actually the addbacks as well?
Exactly.
Yeah.
Exactly. Yeah. So in our first research that we conducted looking at the broiler performance testing, it was necessary for us to acquire soybean meal with no inclusion of addbacks, which is actually pretty difficult. Because in most crush plants, if they have an oil refinery nearby, it's very common to incorporate these addbacks into the meal. Yeah. So a lot of that variation in ether extract is coming from the inclusion of these addbacks.
Very good. Well, no, thanks for helping us understand, one of our key ingredients, soybean meal, that much better. And energy is always a big pressure point for formulation, and we spend a lot of money and time and thought to get that correct. So this is definitely a valuable work you're doing, and we really appreciate it.
Great. Thank you so much.
Well, thanks for your time, Savannah. Thanks to everyone for listening. If you enjoyed this episode, please, like and subscribe on your favorite platforms, and I will see you on the next one. Thank you.